Okay, our next definition is to find the arc length of a polar curve. Arc length of a polar curve. So suppose that the polar curve, it is given by r equals to f of theta, and theta varies from a to b. Okay, and theta varies from a to b, and what we have to do, we have to find the area of this polar curve. Okay, we need to find the area of the polar curve, and you can imagine the figure is the same as like before. So you can imagine this thing. So this is our polar curve, and the polar curve, it is bounded between these two lines which are passing through the origin, theta equals to a to theta equals to b, and we need to find the area of this. What do we need to do? We need to find the length of this curve, means starting from this point, and what you need to do, you need to find the length of this curve from here to this point. So this is our main goal. And what is the formula? The formula is the following: L equals to integration from a to b under the root r square plus dr by d theta whole square. Dr by d theta whole square. So let us do an example. So what is the example? Find the length of the chordoid r equals to 1 plus sine theta. R equals to 1 plus sine of theta. And it is okay, so this is our curve r equals to 1 plus sine theta, and we need to find the length of this curve, and again notice that, if you notice that this curve, it is symmetric about y-axis. Okay, so the first thing you need to notice that the curve is symmetric about y-axis, or you can say theta equals to pi by 2. So what we will do, we will only find the length of the curve to the left to the right of this y-axis. So it means that we will find the length of this portion. Okay, we will find the length of this portion, and after finding the length of this portion, at the end we will divide the length by 2, and that will give us the length of the whole curve. Okay, so we will find the length to the left to this side, and then we will get this thing. But here notice that we are not given the values of theta, so you need to determine the values of theta yourself. But first of all, if you notice that in this formula we have this thing, under the root r square plus dr by d theta whole square. So first we determine this thing and simplify this thing, because simplifying this thing under the square root and the integral sign, it will be very not good. In so to save something, we will do this separately. So r equals to 1 plus sine theta, r equals to 1 plus sine theta. So first you need to find dr by d theta, which will be equal to, the derivative of 1 will be 0, and the derivative of sine, it is cosine of theta. The derivative of sine theta, it is cosine theta. So let's simplify this thing. R square plus dr by d theta square. So it will give us the following: 1 plus sine of theta square plus cosine square theta. Let's expand this first expression, a plus b whole square. It will give us 1 plus 2 sine of theta plus sine square theta, sine square theta plus cosine square theta. And we know from our previous knowledge, that is sine square theta plus cosine square theta, it is equal to 1. So this thing will be equal to 1, and we have one more 1 in the front. So 1 plus 1, it becomes 2. 2 plus 2 sine of theta, 2 plus 2 sine of theta. And when you take 2 outside as a common factor, inside you will get 1 plus sine of theta, 1 plus sine of theta. So what does this mean? So our this expression under the radical, it will become like this. You can write this thing in the following way. So what do we get here? R square plus dr by d theta square. So it will be equal to under the root 2 1 plus sine of theta. Okay, so the next thing is, how can we integrate this thing? The integration of this is, we don't have any formula to integrate this thing. This is the problem. Okay, we don't have any formula to integrate this thing. First of all, you can take this square root of 2 outside. Okay, 1 plus sine of theta. So what you need to do, we have to do the conjugation. We have to do the conjugation. So in order to simplify this thing, what we will do, we will multiply and divide this thing with 1 square root of 1 minus sine of theta. This is a technique which we learned in calculus 2. Okay, so we have this thing, and remember the terms at the top, it will give us the following. Under the root, it will become 1 minus sine square of theta divided by, under the root, 1 minus sine of theta. So how did we get this thing? I will write this thing here. First of all, you need to remember this thing. 1 plus a plus b multiplied with a minus b, it is equal to a square minus b square. So this is the first thing you need to remember. The second thing is, if you have square root of a multiplied with square root of b, it can be written as under the root ab. Okay, and one more thing, from this identity we can also write this thing in the following way. 1 minus sine square theta, it's equal to cosine square of theta. So this will become under the root cosine square theta divided by 1 minus sine of theta. So at the top, this square root cancels with this 2. The square root cancels with the 2, and then it will be rewritten in this form. It will be rewritten in this form. So what do we get here? R square plus dr by d theta whole square. It will be equal to under the root 2. You can bring this term at the top. So it will be written in this form: 1 minus sine of theta to the power minus 1 by 2, and the other term is cosine of theta. So this is our expression for this under the root r square plus dr by d theta whole square. The next thing we need to find out, what are the limits of integration? What are the limits of integration? Okay. So remember this thing. This starts from here and it goes to this point. So here at the top theta equals to pi by 2, and here this is theta equals to minus pi by 2. Theta equals to minus pi by 2, and we are going from minus pi by 2 to pi by 2. So these are the limits of integration. So the arc length, it will be equal to integration from minus pi by 2 to pi by 2, and then you can write these things here. Square root of 2, you can write square root of 2 outside. You can write square root of 2 outside, and then multiply this thing with here 1 minus sine of theta to the power minus 1 by 2 cosine of theta d theta. And which formula we are going to use here? Again, if you remember from your previous knowledge from calculus 2, if you have f of x to the power n and it is multiplied the derivative of inside function, it can be written in this form. Its integral will be equal to f of x to the power n plus 1 divided by n plus 1. So here in this case our function is 1 minus sine of theta, and what is the derivative of this function? The derivative of this function will be equal to, the derivative of 1 is 0 and the derivative of sine is cosine of theta. So we get here minus cosine of theta, but we do not have the minus sign here. So we can multiply, we can put the negative sign here with the cosine theta. Okay, so here with this cosine theta, here we can put the minus sign, and in order to balance the equation we can also write the minus sign outside the integration. So that will give us the following: minus this, and the integration now becomes the following. We are going to add 1 into the power, so this will become minus half. So this will become minus half plus 1, which will be equal to 1 by 2. So it will be equal to 1 minus sine of theta, and that too can be written at the top here, from minus pi by 2 to pi by 2. So this is equal to minus 2 multiplied with square root of 2. First we substitute the upper limit. When we substitute the upper limit, it will become like this: 1 minus sine pi by 2. Okay, and then we substitute the lower limit, it will become 1 minus sine minus pi by 2 minus pi by 2. So this is equal to minus 2 under the root 2, and since we know that sine pi by 2 it is equal to 1, so this first integral, this becomes 0. This becomes 0 because this first expression, this become 1 minus 1, which is equal to 0. But remember, sine minus pi by 2, it will give you minus 1. So from here, from the second thing, what we are going to get, it will become 1 plus 1. The first thing is 0 and the second thing is this one, and outside we have the minus sign, so it is equal to minus minus become plus 2, and then square root of 2 and one more square root of 2, and the final answer will be equal to 4. The final answer will be equal to 4, but what will be the total length? What will be the total length? Because this is the length of the only the right portion. So you can write this thing in the following way: the total length, it is equal to 2 multiplied with 4, and that is equal to 8.